Now we're slowly getting into the world of projectile. Let's start with the one-dimensional vertical toss. First clue I'm going to highlight is the fact that a player set the ball straight up with initial velocity 20.0 meter per second. The second clue that I'm going to highlight is my initial position, which is the height of 2.44 meter. The first part is asking about how high does the ball go before stopping, which implies that we need to find the final displacement. The second part is talking about how long does it take. That means time. Let's illustrate first. So we have initial displacement as 2.44 meter and initial velocity of 20.0 meter per second. The ball left the hand and reached to wherever the location that we don't know from A. Final displacement is what I am going to put. On the other hand, since it's reached the maximum displacement, I'm going to put final velocity as 0.00 meter per second. Don't forget that at maximum height, there should be no speed exist. Of course, don't forget about the gravitational acceleration. We can decide going down toward the person as negative, thus negative 9.81 meter per second square. Now let's divide the space in half for part A and part B. I rearranged some of the variables given and found one kinematic equation, Vf squared that is equal to Vi squared plus 2a delta d, and that will be useful because we don't have any time clue. Don't forget, delta D is difference between final position and initial position. In this case, you can consider as height of the ball's travel. First, I'm gonna rearrange by subtracting Vi squared on both sides. Then I'm going to divide it by 2a on both sides. At this point, we can just cancel out Vf squared because at maximum height, we don't have a speed or velocity. Then we have delta D is equal to negative Vi squared divided by 2a. We can substitute the numbers and units. Once we cancel out overlapping units, we will have only meter, which works because delta D is equivalent as height. Once you punch the number in, you will get 20.38735 meter. That's not our final answer for part A yet, because the question is asking about the how high, which means we need to find our final displacement. So we gotta rearrange delta D formula into dF that is equal to delta D plus di. Simply speaking, you're basically adding the initial position of the ball with height that the ball traveled. Thus, your final answer will become about 22.8 meter. In part B, we are going to use this height that we figured out in the previous question as a clue. You may notice that I chose a different formula because we are going to find the time. I specifically chose the one with the Vf because we don't have our final velocity at the maximum height, so I can simplify the given formula even easier. Thus, only thing we have is delta D that is equal to negative 1 over 2 a delta t squared. I'm gonna multiply by negative 2 on both sides to rearrange. Then I'm going to divide it by a, which is gravitational acceleration on both sides, so that I can isolate for time only. Because it is time square, I'm going to put square root on everything. Once I substitute, I found that meters cancels out except only one left, second. So unit analysis work with time, negative signs also cancel, and once you punch the number in, you will get about 4.16 seconds to reach to the top. Conclusion, the maximum height the ball reached is 17.9 meter and the travel time is about 4.16 seconds. See you next time, y'all.